Alright, let's continue. Now, looking for the dimension of acceleration. I told you guys earlier that if you want to look for a dimension of any quantity, you first need to know the formula of that quantity first, okay? So, uh, acceleration is equal to what? Velocity over time, okay? Now, what is dimension of velocity? Dimension of velocity is what? Is L t raised to power minus 1 then over. Now, what is dimension for time? Dimension for time is what? Is capital letter T. Now, if you go back to the laws of indices, I told you guys earlier that when two base are dividing each other, let's say their power, let's say this one's power is 2 and this other one power is 3. When two equal base are dividing each other, you bring out one of the base, then you what? You subtract their power. 2 minus 3 will give you what? Minus 1. Also, if you check, let's go back to here. Now, if you look at this part very well, you find out that t raised power t and this t raised power minus 1 and this other t, they are what? They are of equal base. So bring out one of the base, then we subtract their power. So minus 1, then remember we subtract their power, okay? This one power is what? Minus 1, then this one power is what? 1, okay? T raised to power 1 is the same thing as what? Is the same thing as t, okay? So the power of this one is minus 1, then the power of this one is what? 1. So we need to subtract their power. Remember, according to indices, when two bases are dividing each other, we take out one of the base, then we subtract their powers, okay? This one power is minus 1, this one power is what? 1. So if we subtract minus 1 from 1, we get what? T raised power what? Minus 1 give us minus 2. So so therefore um okay, t raised power minus 2 then times L, we have what? L t raised power minus 2. So this is the dimension for what? This is dimension for acceleration. Dimension for acceleration is what? L t raised power what? Minus 2. Okay, so in summary, I told you guys that in order for you to look for a dimension of particular quantity, you need to know the formula of the quantity. Like for example, acceleration. Acceleration is what? Velocity over time. And what is the dimension for velocity? Dimension for velocity is what? L t raised power minus 1. Then what about dimension for time? Dimension of time is what? Capital letter T. According to indices, based on the fact that these two bases are the same, we take out one of the base, we bring out one of the base, then we subtract their power. Subtracting their power, we have what? T raised power minus 2. Then multiply it with this L. We have what? L t raised power minus 2. So L t raised power minus 2 is the dimension for what? For acceleration. So plus L t raised power minus 2. Then AT times time. Now what is dimension for time? Dimension for time is capital letter T. So we have what? LT raised power minus 2 then times t. Now if you multiply these two, now if you multiply these two, this multiplying LT raised power minus 2 then times t. Now this is also a law of indices. I told you that is law of multiplication. I told you guys that when two base are multiplying each other, when two bases are multiplying each other, you what? You bring out one of the base. That is if the two bases are equal, or if the two bases are the same, you bring out one of the base, then you add their power. Okay, 2 plus 3 give you 5. Okay, now let's go back to this place. And let's go back to this very place. Okay, dimension for acceleration is what? L t raised to power minus 2. Dimension for time is what? Is t. If you look at it, at, it means that acceleration is multiplying time. Okay, it means that acceleration is multiplying time. So let's go back now. Okay, so dimension for acceleration is what? Is L t raised power minus 2. Dimension for time is what? T. Now, according to indices, based on the fact that these two bases they are equal, I also told you guys that t standing alone is the same thing as t raised to power 1. T raised to power 1 is the same thing as t. So in the place of I can turn it to what? T raised power 1. They are the same thing, okay? Now, according to law of indices, when two bases are multiplying each other and these two bases they are equal, we will bring out one of the base, then what? Add their power, okay? So minus 2 plus 1 will give us what? Will give us minus 1. Okay, so multiply with L, we have LT minus 1. So this is the total dimension. So this is the total dimension here. Okay, so I'm coming. So dimension here is what? L raised power minus 1, then equal to dimension here is what? L raised power minus 1. Then total dimension here will be what? Plus L raised power what? Minus 1. Okay, now according to mass, A plus A is the same thing as what? Is equal to what? 2A. Okay, A plus is equal to what? Is equals to 2A. L plus L is equals to what? 2L. Okay, yes, that is according to mass. Now if you look at dimension for velocity is what? L raised power minus 1. Dimension for acceleration multiplying time will give us what? L raised power minus 1. Now if you look at these two, they are the same. Abi, L raised power minus 1 plus L raised power minus 1 will give us what? 2L raised power minus 1. Remember, I told you guys that A plus A is equals to what? 2A. Okay, yes. So L3 raised power minus 1 plus LT raised power minus 1 to give us what? 2LT raised power what? Minus 1. Okay, so the total dimension in this place is what? L is what? 2L T raised power minus 1. Why total dimension in this place is what? T raised power minus 1. Now, if you guys can recall, I told you guys that values they don't have dimension. Okay, values do not have dimension, so we usually neglect them. Now, in the end of everything, we find out that the total dimension here is the same thing as the total dimension here. This to tell you that this equation is what? Is dimensionally correct. This equation is correct. Okay, yes, this is because the total dimension in this place is equal to the total dimension in this place. Total dimension in this place is what? L raised by minus 1. I told you guys that we usually neglect values. Okay, we usually neglect values that don't have dimension, even symbols they don't have dimension. Okay, adding L raised by minus 1 with another L raised by minus 1 to give you 2 L raised by minus 1. And remember, 2 does not have dimension. Okay, so in the end of everything, find out that the total dimension in this place is anything as standard dimension in this place. Okay, now let's check whether this other equation, whether it's dimensionally correct or not. Okay, now this is what the aux is what aux stand for distance. I told you guys that aux can either be the same thing as s. This equation is setting as s equals to ut plus half at square. Okay, I told you guys that aux can either be is distance or what displacement. Now, if you want to look for a total di if you want to know whether this equation is correct or not, we need to look at we need to look for the dimension in this place. I also need to look for the dimension in this place. Now, if these two dimensions are the same, we know that this equation is correct. At first, let's look for a dimension in this place. Now, what is the dimension for distance? Dimension for distance, I told you guys that distance, length, distance, displacement, altitude, breadth, and width, they all have the same dimension as length. And what is dimension of length? Dimension of length is what? Capital letter L. So the dimension for distance is what? Is capital letter L. Therefore, the total dimension in this place, that total dimension in this place is what? Capital letter L. Now, what about this other place? Now, what is dimension for velocity? Dimension of velocity is what? L raised per minus 1. Then what? Times what? Dimension for time is what? T. Then plus, I told you guys that values they don't have dimension. Okay, so we neglect this half, then we continue with this place. Now, what is dimension for acceleration? Dimension for acceleration is what? Is L raised power minus 2. Then times, remember A is multiplying time here. What is dimension for time? Dimension for time is T. So remember, time here is square, so we put square here. Okay, now let's continue. Equals to, if we solve everything here and we find out that the total dimension in this place is not equal to the total dimension here, you will know that this equation is not correct. Okay, the total dimension in the left hand side is what? Is L. So if this equation is correct, our answer that we will get here will be what? Will be L. Okay, now let's continue. Now, according to indices, I told you guys that the same base when the same base are multiplying each other, when they are multiplying each other, will be what? Usually add their power, okay? T standing alone is the same thing as what? T raised power 1, okay? So we bring out L, then T raised, based on the fact that these two are the same base, we break out what? Break out one of the base, then minus 1, and since they are the same base and they are multiplying each other, we break out one of the base, then we add their power together. So minus 1, then plus 1, then plus this one, this are multiplying each other as well. LT, this one minus 2. Now, based on the fact that these two bases are also the same and they are multiplying each other, we bring out one of the base, then what? We add their power together. So we bring out one of the base. Bringing out one of the base, we have something like this. Then we add what? We add their power. So minus 2 plus 2. Okay? Based on the fact that these two bases they are equal and they are multiplying each other. Had it been they are dividing each other, had it been they are dividing each other, we subtract their power. But since they are multiplying each other, we add their powers together. So adding their power minus 2 plus 2 will give us 0. Okay. So this here will now be what? T raised to power 0. Now, according to indices, whenever a value is raised to power 0, that value is equals to what? Is equals to 1. Okay. Anything raised to power 0 give you what? We give you 1. Okay. A raised to power 0. A raised to power 0 is what? Is 1. Okay. So let's continue. Let's continue. Minus 2 plus 2 will give us what? T raised power. Minus 2 plus 2 is 0. So here will not be what? T raised power 0. And I tell you guys that any T raised power 0 will give you 1. So this T will be what? Will be 1. Then times what? L. Okay. Now let's go to this other part. Minus 1 plus 1. Minus 1 plus 1 will give us 0 as well. So we give us 0 as well. So land with T raised power 0, then multiply it with L, okay? T raised power 0 will give you what? Will give us 1 as well. So times what? L. Anything times 1 will give you that same thing. L times 1 will give us L. Then plus L times 1 will give us L. So the total thing we have here is what? Okay, now let's continue. I told you guys earlier that A plus A is equals to what? 2A. Yes. When the same thing are when we add the same thing together, adding A plus A will give us 2A, B plus B give us what? 2B. Okay? Yes. Now, we have what? L plus L. L plus L will give us what? L plus L will give us 2L. Based on the fact that they are the same, L plus L will give us 2L. So, the total dimension we have here in this place is L. The total dimension we have in this place is what? 2L. Okay? And remember, I told you guys that dimension, and when looking for dimensional analysis, values values don't have dimension. So we neglect these two. Therefore, L is equals to L. This to tell you that this equation is dimensionally correct. This is because the dimension in the left hand side is the same as the dimension in the right hand side. L equals to L. This shows that other this equation is what is correct. Okay, so yes. Now let's move to the next section, which is the most important aspect of this class, section 4. And section 4 is the section is what? Conversion factor. Okay,